on the product. So they must be balanced out. Okay, all right. So we are done with that. Next subtopic for topic 1 is relative atomic, relative isotopic, relative molecular, and relative formular masses. Okay, so these are the learning objective. These are your checklist for subtopic 1.5. So make sure that you are able to cover all of these. Okay, right. Moving on. This is just to remind you, okay, that for the calculation, okay, we are starting to cover, okay, the calculation part of topic 1. Okay, all right. So basic rules in calculation that you should know: when multiplying or dividing measured quantities, give as many significant figures in the answer as there are in the measurement with the least number of significant figures. Okay, so I believe someone tries to get in. Okay, all right. So let's continue. Yeah, when it involves multiplying or dividing, okay, operation, we have to give as many significant figures in the answer as there are in the measurement with the least number of significant figures. Okay, so when it involves multiplication and division, okay, please make sure that for the final answer, okay, you need to be based on significant figures. Okay, all right. And then if it involves addition or subtraction, okay, you need to give the final answer based on the least number of decimal places. Okay, take for example, for example number 1, 6.2 divided by 5.45. The answer is 1.1. So 6.2 has 2 significant figures. 5.45 has 3 significant figures. So your final answer should be based the least number of significant figures. Okay, because it involves division operation. Okay, all right. If it involves addition and subtraction, that means you have to consider to give your final answer in the form of decimal places. Okay, all right. Combination of multiplication or division and addition or subtraction of measurement, final answer follows the least number of significant figures. Okay, so we prioritize in combination of, let's say, for example, we have a minus and this is not minus, this is multiplication. Okay, in combination of multiplication and subtraction, for example, okay, we have to prioritize the multiplication. The multiplication will be performed first, right? So we have to consider for the significant figures, okay, rather than the decimal places. Combination of final answer follows the least number of significant figures. Okay, all right. Okay, this is just a revisit. Okay, it's a revisit kind of thing where you've known about this before. You already familiar with the term use. Okay, so we have relative atomic mass, which can be denoted as A capital, and then we have R there. Okay, R stand for relative, A stand for atomic. Okay, so besides relative atomic mass, we also have relative molecular mass. Okay, and also we have formula mass, relative formula mass. So we have 3 terms here. Okay, what are the difference between these 3 terms? Okay, all right. So the relative atomic mass, the word atomic is focusing on the atom of the element, the mass of the atom of the element. So we are comparing the mass with carbon-12. Okay, the word relative means, actually means you are comparing something with a reference. For example, you are comparing sodium atom mass, the mass of sodium atom with, okay, the mass of carbon. Okay, and to be specific, it is a carbon-12 atom. Okay, so this is the reference, the standard unit that we use in order to determine the atomic mass of the element lah. Okay, so we are actually comparing with 1/12 of the mass of a carbon-12. So, but the highlight here is to make sure that you are able to differentiate if it is present in a form of atom. Okay, single, that means it should be called relative atomic mass. And if it's present in the form of molecule, then it should be called molecular mass. Okay, and if it is present in the form of ionic substances, that means, okay, it need to be called relative formula mass, because ionic, okay, the formula, the ionic compound is made up of formula unit. Okay, it's made up of formula unit. Sodium chloride, sodium plus Cl minus. So those are called formula unit for sodium chloride ionic substance ataupun compound. Okay, alright. So how do we calculate the mass for any of these three terms that we have? Okay, so it's just a simple addition, and maybe we can have the multiplication operation involved there. Okay, so we have Cl2. So this is in the form of molecular form. Okay, this is in the form of molecular form. So this should be called relative molecular mass. Okay, so Cl2, we have 2 Cl atom times with the mass number, the atomic mass, okay, for Cl, okay, which equals to 71. So N2, NH3, and so on. Okay, we total up all the masses in order to get the actual mass of the compound ataupun substance. Okay, same goes to ionic. Okay, only the term used are different, but the to find the mass, okay, are pretty much the same. Okay, all right. Okay, so we are done with that. Okay, this is our focus actually. Okay, relative isotopic mass. Okay, more on elements that are having isotopes. So by definition, the relative isotopic mass is the ratio of the mass of one atom of an isotope when compared with 1/12 of the mass of one atom of carbon-12. Okay, all right. So again, we are referring to carbon-12. One of the reasons why is that so, because carbon-12 is the most abundant isotopes, okay, available in the world, and then it it can be combined with most of the element in the periodic table. Okay, so that is one of the reasons why carbon-12 is our reference, will be our reference mass. Okay, all right, so that's aside. Okay, relative isotopic mass is the ratio of the mass of one atom of an isotope. Okay, guys, so the word isotopic means isotope lah. Okay, one atom of an isotope when compared with carbon-12. So if more than one isotope of element is present, the atomic mass is calculated by taking the average of the relative atomic masses of different isotopes. Okay, all right, so let me just read it again. If more than one isotope of element is present, okay, the atomic mass is calculated by taking the average, okay, the average of the relative atomic masses of different isotopes. Take for example, we have carbon. So carbon has several isotopes. So we have carbon 12, the most abundant isotope for carbon, and then we have carbon 13, carbon 14, and carbon 15. So these two are present in a trace amount, okay, maksudnya sikit, tapi dia still present. Okay, these two, the most abundant one is carbon 12 lah, obviously. So carbon 13 is not as abundant as carbon 12. Okay, all right. So have you ever wondered that in the periodic table, okay, the mass actually represent which isotope? Okay, as you can see, for carbon, there is only one mass. Okay, there is only one mass. How does the mass of carbon was calculated? Okay, so in the periodic table, the mass of carbon is equal to 12.01, if I'm not mistaken. Okay, so 12.01. This actually represent, okay, the average mass. Okay, we need to be fair. Okay, carbon has its sibling. So to be fair, we have to consider all of the isotopes. So that is why the average mass need to be calculated. Okay, the average mass need to be calculated. And one more thing, okay, from the mass number, from the value itself, we would be able to determine which of the isotope is the most abundant isotope. Okay, from the value itself, okay, so we have 12.01 for carbon, right? So we have 4 isotopes, 4 carbon isotopes. So we know from the value, okay, we know that the most abundant isotope is carbon 12. Okay, so this may available ataupun may exist in the world, maybe like dia punya abundance tu, okay, how much it is present, maybe 98%. Okay, this is like 1.5%, okay, the abundance, and carbon 14 maybe 0.00 something, and 15 maybe, okay, total up it should be 100 lah. Okay, totaling up the abundance, the percentage abundance should be equal to 100. Okay, should be equal to 100. Okay, all right. So the value of the mass number, okay, we can predict that from the value of mass number we can predict the isotope that present abundantly in the world. Faham tak? Okay, yang paling banyak daripada value tu kita boleh figure out. That would be the tips lah. Okay, in order to know whether the number to represent the isotope, the most abundant isotope. Okay, all right. Okay, moving on, determining relative atomic mass from isotopic abundance. Okay, how do we determine the mass? Okay, from the isotopic abundance. Like I said just now, abundance mean how much of the isotope are available ataupun exist ataupun present in the world. Okay, all right. Okay, point number 1, element that do not have isotope, for example, fluorine 19, relative atomic mass is the same as the relative isotopic mass. Okay, all right. So some of the elements in the periodic table does not have, some of the elements in the periodic table do not have isotope. Okay, some of them have isotopes. Okay, so to those elements that do not have isotope, okay, the relative atomic mass is the same as the relative isotopic mass. Okay, so for this element, we do not have to consider the average lah, because there is no isotope available for that particular element. So bukan average lah. It is not called average. But those who have isotopes, like carbon kan, okay, element consists of isotopes. The relative atomic mass is the average of the masses of its naturally occurring isotope, okay, weighted according to their abundances. It naturally occurring isotope, maksudnya naturally exists in the world, okay. Apa nama tu, naturally occurring. This one can be represented as abundances. Okay, the percentage that I have mentioned just now. So the percentage shows that the naturally occurring isotope in the world. Okay, all right. So atomic mass unit, AMU, is a unit of mass used to express atomic and molecular weight equal to 1/12 of the mass of an atom of carbon-12. Okay, so like what we have here. So the unit as of now, this is just to introduce to you how the mass, the relative atomic mass, okay, were determined. Okay, so we are focusing on the molecular only. Maksudnya, if we have sodium chloride, one sodium atom, chloride. Okay, one sodium plus cation ion, and then chloride anion. So only these two species. Okay, that's why the formula unit, the unit for this is AMU. Okay, same goes to for molecular. So we have AMU as the unit. Okay, kita belum cerita pasal yang mol tu, yang molar mass. That is another part of the story lah. That will be later on in the slide. Okay, alright. So moving on. Okay, so how do we calculate the average atomic mass? Okay, atomic mass is calculated by multiplying relative isotopic mass of each isotope, okay, by its fractional abundance, okay, also known as relative abundance, and adding all these values together. Okay, adding all these values together. Okay, all right. Yeah, like carbon-12 just now. Okay, carbon-12, carbon-13. All the isotopes for carbon. Okay, all right. So we need to know the mass of each isotope. Okay, we need to know the actual mass of each isotope. Okay, this is what it meant by relative isotopic mass of each isotope. Okay, and this is what it meant by that. This one. We need to know the mass. Saya conteng tu. Sekejap. Okay, we need to know that. Here is. Alright, okay. We need to know the isotopic mass for each isotope. So we need to know the mass for carbon-12, carbon-13, carbon-14, and carbon-15. Okay, so we need to multiply each one of them with their fractional abundance. Fractionals mean pecahan. Okay, so like I said just now, take for example carbon-12 present naturally as 98%. Okay, this one just now maybe 1.5%. Okay, this one agak-agak lah 0.05. Yang ni lebih kurang lah. Okay. So make sure the total should be 100. Okay, so how do we need to transform this natural abundance in a form of fraction. So it will be like this, 98/100. Okay, so this is what we call fractional abundance. So we have to multiply the mass just now, okay, with this fractional abundance. So this is for carbon-12, and then carbon-13, carbon-14, and carbon-15. And lastly, we need to total out, okay, all the mass in order to get the average atomic mass. Okay, average atomic mass. So that's basically this formula lah. Okay, so we have atomic mass, or sometimes it can be called average atomic mass. Okay, if the element has isotope, that means you should know the atomic mass actually representing the average atomic mass. If the element does not has isotope, that means the atomic mass is not the average atomic mass lah. Atomic mass is also known sometimes atomic mass, okay, or it can be called isotopic mass. Okay, so please take note on that. Okay, point number 2, the mass spectrometer is an instrument used to show the identity of isotopes. So we have an instrument that is known as mass spectrometer. Okay, this is used to identify, okay, the identity of the isotopes. So the fractional abundance is plotted on the y-axis, and the MZ, or the mass number, is plotted on the x-axis. So the results will be given in the form of graph. Okay, so this is an example of a graph produced from the mass spectrometer. Okay, so we have percentage abundance. Okay, and then we have mass number kan, mass ataupun MZ. Okay, take for example, we have carbon 12 just now. Okay, so this is carbon 12. Okay, so this is carbon 13 maybe. Carbon 14 and carbon 15. Example. Okay, example. Right, so this is your formula. Okay, it's the formula that will be used to determine the average atomic mass. It's actually the same approach that we apply in order to find the average value. Okay, in order to find the average value. Benda yang sama maybe later on I'll give another example, okay, of our maybe outside of chemistry lah, if you so that you'll be able to understand better. Okay. Okay, so we have example kan. Okay, before we go for example, maybe I can give example like I said just now. It's actually using the same formula as what we have earlier. Okay, take for example, I want to know the weight, the average weight for S22 students. Okay, for example, all right. So in S20 student. Okay, so in S20 we have students, 20 students having mass of 50 kilos. Okay, weight, having weight of 50 kilos, and then another 10 students, okay, having 45 kilos of weight. Okay, so what is the average weight for students in S20? So how would you calculate this? Okay, all right. So the way to calculate this is by find out the 20 students. This 20 actually represent the abundance. Okay, 20 students having 50 kilos of weight over 30 that represent the total number of students, right? And then times with 50. Okay, and then next would be and then we have the value. Okay, and then 10 students just now, 10 over 30, okay, times 45. Then the value. Okay, and then next kita total up these two value to get the final average weight for S20's student. So it's around 48 something lah. Okay, so that is how you calculate the weight, the average weight in this case lah. Okay, because normally to find average we we are given with the abundance is not as many as this. Contohnya one student may have 50 kilos, and then another student has 49 kilos, 45 lah. Okay, so to get the average of these two students, so what we do is 50 plus 45, right? 50 plus 45 divide by 2. Kan? So this is the average because we are dealing with simple number ataupun the abundance is not as many as what we have in here. Okay, so this is actually the same as what we have in here. Kalau tak, or alternatively, conventionally, what you can do is, okay, we have 20 students having 50 kilos, right? So what you need to do is 50 plus 50 plus 50, as many as 20 times. Okay, plus pula dengan 45, okay, ni 20 times, 20 kali, and then plus dengan 45 plus 45 plus 45, as many as 10 times. Divide by 30. You still get the same answer. Okay? Alright, so by using the same understanding of what actually we already knew about this before, okay, we apply in order to find the average atomic mass. Okay? So bukan something yang new. It's something that we know already. Okay, we knew about this already. Okay, right? So maybe we can look at can erase first. Okay, let's look at the example that we have here. Okay, for copper, so copper has 2 isotopes. Okay, so the first isotope is known as copper 63. Okay, this is the abundance or natural abundance of copper 63. So the mass of copper 63 is 62.9396. Okay, and then for copper 65, the mass is given as this, and then find the atomic mass of copper. So by the word atomic mass of copper, it means that you have to find out the average atomic mass of copper. Okay, so it is understood by the word atomic mass of copper when it has, what do you call that, isotopes. When it has isotopes, that means atomic mass of copper is also known as average atomic mass, or it can also be called average isotopic mass. Okay, because it has isotopes. Okay, all right, so you need to have the fractional abundance. Okay, so 69.17 over 100, you will get this value times the mass number. Okay, plus this is the natural abundance, the fractional abundance for copper 65. Okay, this is for copper 65. Okay, so this is the final answer. Okay, all right, moving on to another example. There are 2 isotopes for boron. Okay, so we have boron 10 and also boron 11. Okay, as you can see, the information can be given in the form of what do you call this graph. Okay, so on the y-axis we have the relative abundance. On the x-axis we have the mass number. Okay, so this is the mass number. As you can see, the mass number is are given in the form of what do you call, round off value. Okay, it depends on the question. Okay, sometimes it can be given in the form of this, and sometimes it can be given in the form of this. But okay, please do not round off the value before you even start calculating for the final answer. Okay, do not. Okay, please guys, do not simplify. Okay, do not round off. Okay, these are the values given and then somehow tak tahulah macam mana the student just simply round off. Okay, 62. Okay, nak senang calculate, jadikan 63 lah. Okay, please do not do that. Okay, use as is, use as is, use as it is. Sorry, use as it is. Use the value as is. Do not change anything. Do not alter anything. Okay, because the value itself represent precision and accuracy. Okay, especially when we are handling an instrument. Okay, the value dekat belakang tu represent precision and accuracy. When you change the value, you simply round off the value to the nearest number. Okay, it's you are actually introducing error tau. Okay, because it's no longer the actual value. When you round off things, when you round off values, okay, you are actually introducing error in your calculation. Because it's no longer this the values that we want lah. Okay, all right. So carry forward, okay, follow through from the start until the end, and then lastly, okay, give your answer based on significant figures or what do we call that, decimal places. Okay, jangan, saya tak tahulah macam mana student, okay, somehow they just do it. Okay, they just simplify things so that it would be easier for them to calculate. Okay, so don't do that. Please do not do that. That is my strict warning lah. Okay, do not do that. Okay. Alright, as you can see, this is boron 10 and this is boron 11. Okay, alright, so from the information, only 1% abundance is provided in the question, which is for boron 11. Okay, but not to worry, we know that the total of both isotope, the total abundance of both isotopes should be equal to 100. Okay, so abundance, total abundance, okay, total, it should equal to 100, regardless how many isotopes we have for that one particular element. Okay, alright, so we can just simply, ni dia dah bagi dah, 81.3 and then 18.7. Okay, sometimes it's not given. Okay, sometimes one of the percentage abundance is not given, but it is understood that you have to just simply minus the value in order to get the remaining percentage abundance. Okay, right. So once we have that, we have all the values, we can insert into the formula and we finally calculate for the final answer. Okay. Yeah, we have checkpoint. Okay, please complete this checkpoint now. I give you maybe 3 minutes, okay, for you to complete the checkpoint. Okay. Any questions so far, guys? Okay, maybe I'll check on the chat box whether we have question from the floor. Anybody? Dekat calendar saya. Okay. So far we don't have any question related to the lecture. Okay.
Madam. Hello, madam. Madam,
Yes,
I have a question. Kalau ada darab dengan tambah tu, dia kena ambil berapa significant figure?
Darab dengan tambah. So the final operation involved is positive, what do we call this? apa nama, final operation is addition kan. So it will be based on decimal places lah. Okay, so this one we have 3 decimal places, this one we have 0 decimal places, okay, this one we have 3 decimal places, this one we have 0 decimal places, kan? Alright, so the final answer should be based on 0 decimal places lah.
Oh,
Okay?
okay.
Sebab look for the final operation. So the final operation is addition operation. Okay, so you have to identify all the numbers based on decimal places. So this is 3, this is 0, okay, 0 decimal places, this is 3, this is also 0. So the least number of decimal places that we have here is 0. So your final answer should be 0 lah. Okay, all right. Oh, I forgot to remind you just now. Okay, during calculation, follow through, okay, from the start to the end. Just maintain as many number as possible in your calculation, because obviously we are using calculator. Okay, so we have made so as many number as possible lah yang muat in the calculator kan. But the final answer tu kita kena make sure that it should be based on decimal places or significant figures. Okay, you nak tulis final answer tu, okay, check on the values that we have here. Okay, so we have 81.3, and then we have this is 0.813. Okay, this is 0.187, and then the mass we have 10, and then we have 11. Okay, and then from there we can come up with the final answer. By the way, the lecture for the video for our lecture, okay, will be uploaded in my Google YouTube channel. Okay, so please, you can find the videos for lecture, okay, given in the Google, the link is given in the Google Classroom. Only for the lecture, for tutorial, I'll upload it on the Google Classroom. Okay. All right. Are you done, guys?
Madam,
Yep.
Kan kalau kita nak kira yang relative molecular mass tu, lepas tu kalau macam dalam soalan kan, dia ada bagi tak untuk satu tu dia punya mass? Ke dia tak bagi?
Come again?
Tak, kan kalau nak kira yang relative molecular mass tu kan, kalau macam dalam soalan dia ada bagi tak macam Na tu 23 semua tu? Ke dia tak bagi?
So supposedly the information will be given in the question. Okay, if not, okay, in the exam we will provide you the list of element, okay, complete with their atomic mass number, okay, mass number and also atomic number kan. Okay, you will be given a list of elements complete with their mass number and atomic number. Okay, for you to refer to lah. Okay, for you to refer to. But definitely we will not be providing you with the predictable. Okay, that is not going to happen lah. Okay, so alternative to that, a table will be given to you. So you have to sort. You have to find the element mentioned in the question, okay, from the table given. It will be in the appendix, okay, of the question, of the exam question. Okay, all right, any other question? Okay, are you done with checkpoint 10, guys? Please respond.
Yes.
Done but wrong.
Okay, okay, did you get the answer? Did you manage to get the answer?
No.
Yes.
No.
Why is it?
No.
No. What did you get for
Yes.
lithium?
Yes.
What's wrong? Okay. All right. Oh, okay. This is the type of question. Okay. Let's go through the question together. The isotopic masses of lithium-6 and lithium-7. So this is lithium. So we have lithium. Lithium has two isotopes, which is lithium-6 and lithium-7. Okay. Are given as 6.01512. So this would be the mass for isotope lithium-6, 1512. Okay, and then lithium-7, we have the mass is equal to 701601601 AMU. Okay, don't forget the unit, guys, AMU. Okay, if the atomic mass of lithium is the atomic mass of lithium, so this is the average. Okay, this is the average mass of lithium, atomic mass for lithium. Even though it does not mention average, but you should know, it is understood that when it has, isotopes, alternative to atomic mass is average atomic mass. Okay, ataupun isotopic mass. Okay, is equal to 6.94. Calculate the percentage abundance of two isotopes. Okay, all right, so we have the mass already, but the problem now is we do not have the information on the abundance for each lithium-6 and lithium-7. Okay, so that's the thing now. So we have to find out the abundance, percentage abundance. So how do we do that? So, okay, we know that lithium has only two isotopes, right? Okay, so total of these, like I said just now, total of these two abundance will be equal to 100. Okay, so by that we have two unknown here. Okay, we have two unknowns. So we have X and Y. So we have two unknowns, right? Okay, but we can connect these two. Okay, if we assign the percentage abundance for lithium, abundance of lithium-6 is equal to maybe X. Okay, that means the percentage of abundance for lithium-7 should be 100. Okay, minus 100 minus X, right? Okay, if we just straight away convert the percentage in the form of fraction, so fraction, understood lah kat sini understood. Okay, so it will be 100 over 100, which is equal to 1 minus X. Okay, all right, so once we have this, then it will, follow through lah. Maksudnya we need to find the X, and then after we find out the X, we will be able to determine both abundances. Okay, ini je kat sini dia punya tricky part dekat situ. The rest are all self-explanatory. Okay, so see, like I mentioned just now, you have to what do we call it? Justify. Justify, is it? Okay, you have to justify.
Madam,
Yep.
kalau yang lithium 6 tu yang buat 1 minus X, sama je kan?
Sama je. Okay.
Okay.
It depends on which one you define as X lah. Okay, if you go for lithium-6, then X would be for lithium-6. Okay, if you go for lithium-7 for X, then it's the other way around. Okay, all right. So please make sure that you really understand, okay, the apa nama tu, the working solution, okay, so that you'll be able to recreate if you were asked to do so. Okay, so this is the kind of style ataupun the pattern that that examiners ataupun in your exam, okay, you will find this pattern that will have higher tendency to be coming out in the exam. Pattern-pattern yang tricky macam ni. Okay? Alright. Okay, another example. Okay. Another example we have here is a question. Okay. Alright, so try to complete this, guys. Checkpoint 10. Okay, are you done, guys? Hello, are you done?
Yes.
Yes.
Okay, maybe let's have someone to read out your answer. Okay, did you manage to get the same answer as what we have in the slides just now? It's 106.91. Okay, this we have apa nama tu very small correction on the final answer. It should be 106.91 as if I'm not mistaken. I was told that we have a slight correction on the final answer. Dapat ke? Everybody? Did you get the answer?
Dapat.
Alright, good. Okay, so dah tahu
Mine is
this from this previous question, then you somehow boleh baca the type of question that can be asked for the question for apa involving atomic mass. Okay, alright. So the keyword is here. The hint. Okay, so it's given in the form of fraction, mass ratio. So Ag 109 over Ag 107. Okay, is equal to 1.0187. Right, so how do we find the mass of Ag? Right, okay, so you can choose any which one, okay, you would like to proceed. So the easiest will be this one lah. 1.0187 times, okay, this one go up, then become Ag 107. So Ag 109 is equal to 10187 times Ag 107, and then insert into the formula. Okay? Yep, this is the answer. Okay, you simplify this into this, the one that given in the question. Okay, you simplify that into this. Okay, another checkpoint. Okay, this checkpoint is very much the same as what we have for our example just now. The difference is just in terms of the number of isotopes. Okay, previously we used to have 2 isotopes. Okay, so this time around we have 5 isotopes. That's all. Okay, they're quite straightforward lah. So because we have each information for each isotopes. Okay, so are you done? Are you done, guys?
Yes.
Yes.
Yes, done.
Okay, please respond lah. You guys ada berapa orang guys tu? Okay, we have S19, S20, S33 and S34. Okay, so there are 4 groups in one session. But the response is like so hamba one. Okay, so please respond. Okay, all right, so let's just go through the answer. So we have 5 isotopes for zinc. Okay, all right, so yeah, okay, insert into the formula and then we have the final answer as 65 AMU. Okay, right. Any question related to average atomic mass so far? Are you guys doing okay? Can you guys follow?
But my
Yes.
answer has.
Yes.
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 Okay, all right, good. Thank you. No question, okay? Let me check. Ada dengar bunyi message kat situ. Yes, okay. All right. Thank you for the response. Anybody? Somebody? Yes, Shaza. You want to say something, Shaza? Shaza, we cannot hear you. Okay, if you have problem with your, yes. If you have problem with your mic or whatsoever connection ke, you can always type in the chat box, okay? All right. Okay, next is 1.6, the mole concept and Avogadro's constant, okay? All right, so this also has been taught to you during your SPM time, okay? So it's something that you have learned before, so I hope it will be advantageous for you, okay? Because this subtopic is apa nama tu, has been introduced in the Asasi. Okay, all right. So you know about this before. You've learned about this before. Okay, all right. It's not something new. You are already familiar with it. Okay, so we have 2 learning objectives, 2 LOs for this subtopic. Okay, make sure that you are able to explain the mole in terms of the Avogadro's constant, then calculate the number of mole of elements or compound given its mass and molar mass and vice versa. Okay, okay, the mole and Avogadro's constant. Okay, so a mole or it can be abbreviated as mole. So this is the unit. Okay, if you were asked to calculate the mole, okay, the unit should be MOL, not this one. Okay, this is the term, this is the unit. But it's not a major problem if you were, let's say you somehow accidentally written as MOLE, then MOL as your final unit. Okay, not a big problem. Okay, abbreviated mole is the amount. Okay, a mole is the amount of any substance with the same number of entities as there are atoms in exactly 12 grams of carbon 12. Okay, all right. So again, carbon 12 is our reference mass. Okay, Avogadro's constant. Okay, we have this value 6.022 times 10 to the power of 23 mole negative 1 give the number of entities in 1 mole. Okay, if I were to simplify what mole is, okay, mole is what we call in Malay as penjodoh bilangan. Okay, mole is a penjodoh bilangan for atoms or molecules or a formula unit or whatsoever. Okay, so atoms has its own world. Okay, it need to have its own suitable penjodoh bilangan. It's not like us. Okay, in our world we use dozen, right? So dozen, we have dozen. Dozen represent 12 entities. Okay, and then we have pair, 1 dozen, 1 pair. This one means 2 entities. Okay, all right, but if we have 1 mole, it means that the number of entities is 6.022 times 10 to the power of 23 entities. Okay, because we are dealing with atoms, the tiniest particle, the smallest particles, okay, for a matter. Okay, we cannot just simply say we have 1 dozen of oxygen atom. Okay, it doesn't work that way. Dia tak macam tu, 1 dozen of oxygen atom. No, in 1 drop of water, okay, we have millions of, maybe thousands of water molecule in there. So it's not suitable to use dozen, pair and whatsoever to be used as the penjodoh bilangan to represent atoms or particles, again ions and whatnot. Okay, so we have to have atoms, and those others, okay, should have its own penjodoh bilangan, which is known as mole. Okay, so mole represent the number of entities in mole is equal to 6.022 times 10 to the power of 23 entities. The entities can be in the form of atoms, molecules, ions, okay, formula unit, okay, what else? It can be in the form of that. So that's why I put in entities. Okay, it does not restrict in terms of the type of entities that can be used for mole. Okay, in our world we do not use kita tak, our penjodoh bilangan will not be able be as much as 1 mole. Kan, 1 mole tu adalah this much. This is a lot, 10 kuasa 23. Can you imagine how many zeros we have entailing the numbers, the figures? So banyak. Okay, so in our world we do not involve with this amount. Kita taklah sampai ke imagine the number of human in this world. Okay, sampai nombor Avogadro tu. I don't think so. Okay, tak tahulah in the future kan. Alright. Kalau kita total up from the beginning of the world, pada mulanya world ni exist until now, maybe it would reach to this number. Okay, but for atoms, 1 mole is considered very small. Can you imagine if we have 60 mole of particles, okay, 100 or 1,000 mole. So can you imagine the number of entities that we have for that 60 mole? Okay, baru 60 kan, tapi the entities in the 60 mole. So it will be a lot. Okay, so give the number 4 entities in 1 mole. Okay, so this is an example for 1 mole of substances. Okay, so we have sulfur here, and then this is aluminium, this is copper, and this is mercury. So all of these are 1 mole. Okay, all of these are 1 mole. Okay, and then all of these are having what we call that entities, or we call it as atom lah. So because all of these are in a form of element kan, so they exist in a form of atomic element. Okay, so the number of atoms, entities in this case is atom, okay, are present for each one of them are 6.022 times 10 to the power of 23. So this is 1 mole, 1 mole, 1 mole, 1 mole. But okay, so please take note on that. So far we have this relationship, 1 mole, okay, equal to 6.022 times 10 to the power of 23 entities. Entities can be anything, okay, related to atoms lah. Okay, and then one more thing that you need to to be sure of is 1 mole is also equal to its molar mass, which later will be covered in the slides. Okay, all right. Okay, even though they are all 1 mole, but the mass are different. Okay, the masses for each one of them, okay, the masses are different. Faham? So depends on the molar mass lah. Okay, it depends on the molar mass. The word molar mass, molar, mole. The root word for molar is mole. Mass is mass lah. Okay, that means the mass for 1 mole. Okay, so we know that this is 1 mole. That means the molar mass will be referring to the mass that we have in the periodic table. Okay, all right. So molar mass, again, like I said just now, is the mass of 1 mole of a substance. The word molar come from mole. Okay, mole means 1 mole lah. Okay, the mass means mass lah. Okay, so the mass of 1 mole of substance. Okay, so we know that the molar mass of substance is gram per mole, m is mass, n is the number of mole. So by using formula, okay, you know about we know that the formula of mole is equal to mass over molar mass. Okay, if we want to find the molar mass, then we could rearrange this. Okay, and then we will end up with this m over n, m over mass over mole. Okay, all right. So this is another example that we have. This is another relationship so far. Just now we have 1 mole is equal to number Avogadro. Okay, Avogadro's constant. And then we have 1 mole is equal to molar mass. The mass of 1 mole of substance. Okay, this is something yang kita dah tahu dah benda tu. Okay, we have that information already. Okay, so you can be asked in a form of maybe in the question you were asked to find the mass of substance, the mole of substance, or even the number of atoms of molecule present. Okay, or you can be asked about the molar mass and vice versa lah. Okay, so it is in terms of calculation. It can a variety of question can be asked in the form of this. Okay, example, calculate the number of copper atoms in a penny weighing 3.10 gram. Okay, so normally when you have 3.1, okay, the question is asking for number of copper atom. Okay, so we know that penny is made of copper. Okay, so in 3.10 gram of penny, how many copper atoms are present? Okay, all right. So normally student will go for this method. Okay, using the what we call the formula. Okay, so the mole of copper. So we have the mass dividing with its molar mass. So molar mass, and then we have the final answer. And do not stop there because the question is asking for the number of atom. Okay, so we proceed further. Okay, we have to multiply with the what we call this Avogadro's constant. Okay, all right. So this is the final answer. Okay, all right. The problem is, the thing about student is, they use this method, somehow they leave behind the unit. Unit is not their habit, okay, to be written, and suddenly for the final answer, the unit appears. Okay, the unit appears. I'm not sure whether masa sekolah dulu you were taught to, I mean, that is the way for you to represent your answer. Okay, because mungkin maybe okay, during your SPM time, the focus is more on how student can learn the relationship between atoms and Avogadro's, atom and molar mass and whatnot. Okay, maybe the focus is that part lah. So tapi by right, technically it is wrong. Okay, how can you neglect the unit and then suddenly the final answer ada unit? You mengada-adakan something yang tak ada kepada ada. Okay, you kena follow through lah. So you need to have the unit, and then the unit will be cancelled out, and you will be end up with mole. Kan, mole -1 kita bring up, we will have mole as the final unit, and then this mole kita carry this one. Okay, it should be atoms mole -1, so this mole cancel out with this mole. Okay, mole -1, so we will end up with atoms. Okay, unit actually help us to sometimes help us to identify which part of the calculation is wrongly calculated. Okay, dia membantu sangat sebabnya if you are using only the values, you tekan calculator je, you tak tahu pun yang your calculation is actually wrong. Okay, but unit help us to identify that. That is why unit is important. Okay, so please, okay, so let bygone be bygone lah. Okay, what you have learned masa your SPM time tu okay. Alright, you have updated, okay, your knowledge in Asasi. Okay, you know that you need the unit. Okay, unit is compulsory lah. Let's just say compulsory lah. Okay, alright, to make sure that we are on track. So please include the unit. So I will check your tutorial answer and I'll comment on that. For those who did not include the unit, okay, I'll definitely comment on that. And then saya memang akan sakit hati lah. Okay, this calculation then suddenly final unit. Okay, but it's okay. I believe that is a learning process. Okay, I will tegur you. Confirm saya akan ni lah, saya akan comment on that. Okay, alright. That's the thing when you are using formula tau. When you are using formula, you tend to miss out the unit because that is not your habit to include the unit. But if you are using this method that is known as dimensional analysis, I'm sure that you are also familiar with this because I was told that dimensional analysis is also introduced in your physics. Am I right? Can someone please respond about this?
Yes.
Yes.
Consistent.
Yes.
Yes.
Yes. Okay. Thank you.
Yes.
Thank you for the response. Very
Yes.
everybody seems to be agreeing with my statement just now. Okay, you have learned this in physics. And saya personally, okay, I favor this dimensional analysis. The word favor means later on, I'll be using dimensional analysis rather than using this. So you have to keep up with me. Okay, I'm not going to change into this method. I'm going to stick with this dimensional analysis, so you have to keep up. Okay, kalau lambat ke apa ke, then you have to work hard lah. Okay, if not, the best way is for you to learn this dimensional analysis. Okay, student biasalah for the first time they heard, not student lah, everybody pun, when you heard something new for the first time, you will try to, bukan reject lah, I mean you will be reluctant to use it. Okay, but once you get to know it and you find it is easier and it helps a lot, then you will switch to the whatever lah you are trying to get used to it. Okay, alright. So let's use this one. Okay, the main thing about that using dimensional analysis, you need to know the relationship. Okay, that relationship is known as conversion factor. For example, okay, so far we have 1 mole is equal to, okay, let's just refer to this question. So 1 mole of copper atom, 1 mole of copper atom is equal to number Avogadro constant, which is 6.0222 times 10 to the power of 1023. copper atoms. Okay, right. So this is the relationship that we have so far, and then one more, we have 1 mole of copper atoms. Okay, 1 mole of copper atoms is equal to the molar mass of a copper, which in this case it is 63.5 gram per mole, 63.5 gram. Okay, this is the mass of copper tau. Tak payahlah includekan dia punya unit. This is what it meant. Okay, gram per mole, you know what gram per mole means? Okay, kalau 63.5 gram per mole, it means that 1 mole, okay, 1 mole of copper atom, the mass is equal to 63.5 gram. Okay, I hope that everybody knows this. Okay, jangan tak tahu pula. By unit itself, we will be able to understand what is the relationship between the values. Okay, all right. So we have these two. Okay, this will be our conversion factor. Okay, so first, okay, let's start with the value given from the question. Okay, so we have. Okay, let's just use another in color. Let's have maybe purple. Okay. Okay, so given is 3.10 gram of copper. Okay, include all. Gram of what? Gram of copper. Okay, and then next. Okay, multiplication. Okay, darab, and then what garis? Okay, straight line. This is division. Okay, this is the conversion factor that I have mentioned just now. Okay, so the hint ataupun the tips is to make sure that the unit at the denominator here should be the same as what we have here. Okay, so the values have gram of copper as the unit. So dekat bawah, the denominator should be having the same unit, gram of copper. Okay, gram of copper. And then gram of copper, so gram of copper. Okay, so from the conversion factor, the relationship that we have here, okay, so look for values indicating gram. So we have this, the second relationship kan. Alright, so we want the gram of copper, so it should be molar mass, so 63.5 gram of copper. So when you are using this one, you should remain this. Okay, so atas dia should be 1 mole copper. So this is the relationship then that stands for 1 mole of copper is equal to its molar mass. Okay, they mesti have relationship tau. It cannot be 63.5 gram of copper, suddenly kat atas ni 2 mole of copper. So what is the relationship between 2 mole of copper dengan the mass of copper? There's no relationship. Therefore salah. Okay, it cannot be used. So you don't have that justification. The justification that we have here is what we have learned so far, 1 mole of copper is equal to its molar mass. Okay, and then it will be cancelled out. So the gram of copper will be cancelled out with gram of copper that we have here, and we will end up with the unit. Okay, mole copper, and then tekan calculator, okay, to find out the value for the mole of copper, which is 0.0488. Okay, as you can see, so nampak tak dia carries the unit tu, because we have to have the unit. And then moving on, so next we have 0.0488 mole. You can further the calculation, or you can maybe kalau beginners you can take one step at a time. Okay, so we have the final answer just now, 0.0488 mole copper kan, mole of copper atom. Okay, alright, so we want the final answer to be in the form of number of copper atom. Okay, so darab again, buat garis. Okay, so mole, the unit should be mole of copper for the denominator. Alright, so we want it to be, the final answer should be in the form of atom, copper atom. Okay, copper atom. So what is the relationship that is suitable to be used now? Okay, the most suitable one would be the first one lah. Boleh tak pakai yang bawah ni? Boleh, tak salah, but it does not answering the question. Okay, you can place mole of copper, 1 mole of copper, and then you place dekat atas ni mass of copper. You can do that, but at the end of the day, will that answering the question? No, it won't. Okay, so instead of taking this second relationship, we take this one as our conversion factor. So what is the relationship? So bawah we should have 1 mole of copper, and then okay, this will be our nominator. So it is 6.022 times 10 to the power of 23 copper atoms. Okay, all right. So this one will be cancelled out, and we will end up with copper atoms as our final unit. Okay, when it get cancelled out, okay, dia boleh di-cancel. That means your values and your units are all correct. Kalau it cannot be cancelled, okay, cannot be cancelled. Somehow dia ada extra ke apa ke, that means there is something wrong somewhere. So please recheck. Okay, kalau you tak buat unit, you main tekan calculator je, that will be your final answer lah. Itu tiba-tiba you tambah the unit. So it does not help you lah in order to identify which part of your calculation is actually wrong. Okay, so we need this to help us to make sure that we can come out with the correct final answer, with the right final answer. Okay, all right. Okay, so the time now is 4:35. Okay, let's hold on to this first. We proceed to the next slide. Okay, the mole of gases, and then we will continue to the previous slide, the checkpoint lah. Okay, all right. So far we have 2 relationships just now. Okay, it can be used as our conversion factor. Okay, moving on, we have mole of gases. Okay, the volume occupied by 1 mole of any gas is known as molar volume. Again, this could be our conversion factor. The word molar, like molar mass just now, molar, okay, the root word is mole. Okay, that means for 1 mole. Okay, for 1 mole. What is the volume for 1 mole of gas? Okay, the volume for 1 mole of gas. So berapa? Apakah dia punya, what is the value for the volume? Okay, but before that, we have 2 conditions that we need to consider. One is at STP, that is known as standard temperature and pressure, STP. Okay, the other one is known as RTP, room temperature and pressure. Okay, if it is at standard temperature and pressure, that means the conditions for the temperature is at 0 degrees Celsius and the pressure is at 1 atm. You have to know this, you have to memorize this, you have to remember this, okay, when the question mentioned STP, okay, so you should know that it is at temperature is equal to 0 and 1 atm. And then one more thing, you need to know that at STP, if it is a 1 mole of gas, then the volume should be equal to 22.4 liter. Okay, the volume is equal to 22.4 liter. Okay, all right. So this is by formula. You may use this. Okay, you may use this as your formula. Mole substance of gas is equal to volume of gas in liter over 22.4 liter mole at STP. Okay, all right. If not, you can also use the dimensional analysis. It's not a problem. Okay, the word liter per mole. What does it mean by liter per mole? 22.4 liter per 1 mole, kan? It shows that for 1 mole of gas, the volume is equal to 22.4 liter. So that is the relationship. Okay, all right. So for RTP, room temperature, that means at 25 degrees Celsius and at 1 atm. So the volume is 24.0 liter per mole. Okay, don't get confused because both of them have number 4 in the values. Okay, so don't get confused with them. STP 22.4, RTP is 24.0. Okay, right.
Madam,
Yep.
L dengan DM3 sama
Yes, L is equal to dm cube and milliliter is equal to cm cube. Okay, and just straight away convert liter to dm cube. If you are given in a form of dm cube, just straight away convert into liter. If you are given in a form of cm cube, convert into milliliter. You don't have to show us the calculation. Don't. Okay, we do not want to know that. Okay, so straight away, just might as well you memorize that liter is equal to dm cube, milliliter is equal to cm cube. So this is the normal what we call normal unit, okay, that commonly used in our syllabus lah. Okay, commonly, but we can also ask alternative to this, like cm cube, other than cm cube, meter cube, okay, but very rare lah. Okay. So another addition of conversion factor would be this one. Okay, mana tadi this one? Yep, this one. This is for STP, and then this is for 1 mole of gas is equal to 24, okay, 24 liter. Okay, 24 liter. Liter lah, jangan liter per mole pula sebab sini kan dah tunjuk 1 mole. This is 1 mole is equal to 24 liter. Okay, the unit is liter. So dah ada, so far we have four relationship that we can be that can be used in our dimensional analysis, okay, solving problem. Okay, alright. So example for molar volume. The decomposition of KClO3 produce 48 liter of oxygen gas. Okay, how many moles of oxygen gas are there, and calculate the mass of oxygen gas at STP. Okay, at STP. So there are two questions asked here. So one is mole in the form of mole. The other one is in the form of mass. Okay, so make sure you address both questions. Okay, so if we are using the formula kind of approach, then you will be using this. Okay, alright. So insert the information. So volume given is 48 liter. Okay, so this is the one that we have. Okay, so far for the volume 24 liter per mole at STP. Okay, so the mole is this, and then find out the mass. Okay, as you can see, we will this one liter will be cancelled out. Nampak tak? Liter cancel out, so we will end up with mole negative 1. So mole negative 1, okay, kita bring up, it will become mole. Okay, alright. So mole cancel out. That's why we ended up with gram. That's why dia ada gram. That's tu bukan tiba-tiba dia tambah gram guys tu. Okay, that's why saya geram sangat when suddenly there's no unit, then final answer there's unit. The unit appears. Okay, alternative to this, okay, let's try out using dimensional analysis. Okay, alright, so we have the information. So we have 48.0 liter of what? Of oxygen gas. Okay, oxygen gas means O2. O alone is oxygen atom. Okay, so please do know what is the differentiate, do know how to differentiate between these two. Okay, it will be differ in terms of the molar mass later on. Okay, alright. The conversion factor will be based on the unit here. So we have liter of oxygen there. So it should be liter of oxygen. Okay, alright, liter of oxygen. Okay, so far, okay, the relationship that we have just now, 1 mole at STP, 1 mole of gas is equal to 22.4 liter. Here, okay, 22.4 liter of gas. Okay, so liter dekat sini, so it should be 22.4 liter of oxygen gas. So the The denominator should be 1 mole of oxygen gas, O2 lah. Okay, exactly like what we have here. Ni kat sini. This is a relationship. Kita just pakai sahaja. Okay, alright, so calculate. Okay, this liter of oxygen will be cancelled out and then we will end up with mole. So it is 2.14 mole of oxygen. See? Lengkap, complete. Okay, and then you can carry out apa nama tu straight away, or you can tapi the question is asking for mole kan, mole and mass. Okay, next step, so this will be the mole for the gas. Next step will be by using the values for the mole value. Okay, we want to calculate the mass kan. Okay, so remember this one should be carried here. Okay, mole O2. Okay, mole O2 dekat sini yang atas ni kena dekat bawah. Okay, okay. Katakanlah saya nak, I want to use this and I'll continue until mass. Okay, until we calculate for mass. Okay, 48.0 liter of oxygen. Okay, alright. Okay, liter of oxygen, then it should be 22.4 liter of oxygen. So at the top we have 1 mole of oxygen. Okay, if we were to calculate the mass straight away, that means okay, so tengok dekat atas, yang dekat atas tu ini pun sebenarnya over 1, betul tak? Okay, so mole of oxygen. So at the bottom should have the same unit as at the top. Okay, so like what we have here. So we want it to be in gram later on. Okay, we want it to be gram later on. So we have the relationship 1 mole is equal to its molar mass. Okay, 1 mole and then the molar mass should be 32 gram of oxygen. 32 gram of oxygen. Janganlah gram per mole pula lagi sebab kat bawah kan dah ada mole. Okay, so 32 gram of oxygen. So the unit, we have only 1 unit lah. For beginners, as of now, let's just maintain for single unit. Dia tak ada gram per mole ke whatsoever. If you are advanced, okay, advanced user of dimensional analysis, you can play around with that. Okay, this does not necessarily be at here. It can be placed at the back. As long as it can be cancelled out. That one is for advanced. Okay, so as a beginner, as an amateur, let's just do the simple way dulu lah. Cancel out. Okay, that's why we will end up with this gram. Okay, so 68.5 gram of oxygen. Alright, okay. Any questions so far, guys?
No.
Alright, if there is no question, maybe you can try out, let's try out this checkpoint, maybe. Okay, cuba try checkpoint 12.
Madam,
Yep.
soalan tadi tu, macam boleh kita jumpa molar mass dia?
Macam mana?
Kita boleh jumpa molar mass dia. Boleh jumpa dekat mana?
This one, for this one, is it?
Yeah.
Oxygen. Molar mass. You should know lah molar mass. Or you can refer your periodic table. Okay?
Oh, okay. Okay, thank you, madam.
Main group element, especially group 1, group 2, group 13, 14, 15. The first row, I would encourage you to memorize those elements. Okay? Yes, it's true that it will be given in the question, but like macam tutorial macam ni kan, it's not given kan. So you should find out on your own lah. Okay, but it's best to memorize lah. For oxygen, what would be the molar mass for oxygen atom? Then it should be 16. If it's oxygen gas, then it should be 16 times 2 is equal to 32. Okay, so those main element, especially from group 1 until group 1 to all the main elements lah, without the transition element. Okay, first row and second row, the first 2 row. Okay, make sure that you memorize them so that cepat. Okay, later you nak check on the table, the appendix later on, it consume a lot of time lah. So let's just keep that step. Okay, remember, memorize, and then you will have no problem to use it right away. Okay, but whatever it is, please refer to the question. Sometimes it will be given in the question. Sometimes you need to find out the mass from the given appendix kat belakang soalan belakang tu . Tapi for tutorial and checkpoint, refer lah periodic table sendiri. Okay. Okay, dah ke? Are you done? Everyone?
Not yet.
Not yet, okay. It's okay. Take your time.
Madam,
Yep.
berapa tempat perpuluhan?
40-an. Tengoklah final operation is based on apa? Final
Multiply.
operation.
Multiply.
Multiplication kan, it should be based on significant figures lah. Okay, so we have look at for the values that we have. So we have 20 liters. What else? STP. Okay, temperature for STP. What STP is
20.
Zero kan? Sorry, okay. Is it? Zero lah. 20 kan? Sorry. STP, zero. So zero. Okay. One significant figures. And then pressure 1 atm. Pressure 1 atm. Okay, 1 atm, that means dia one significant figures. This is one significant figures, this is one significant figures, this is 1, 2, 3 significant figures, right? So pilih the least lah, the least significant figures.
Oh, thank you.
And then it depends on the final operation lah. Okay, so you kena consider the values. Look for each values and then identify the least significant figures. Okay. Carbon dioxide. Carbon is 14. 2 oxygen. Okay, try using dimensional analysis. Okay, so that you can practice. Okay, just to show you how does the dimensional analysis looks like later on. So this is what we call dimensional analysis. Okay, as you can see, it is horizontal. Okay, if you are using your conventional way, is going down, okay, ataupun vertical. So horizontal is much more space friendly. Okay, space friendly. So everything is in one line. But for your conventional method tu, they go down and then belum cerita lagi dia bersepah kat mana-mana kan. Okay. So dia more structured, more apa nama tu, space friendly. Okay. Alright, so let's discuss the answer, guys. Okay. Okay, right. Okay, given is the carbon dioxide is obtained from the fermentation of glucose. If 20 liter of carbon dioxide, okay, CO2, at STP are collected, calculate the number of oxygen atom. Okay, number of oxygen atoms. Number of oxygen atom, yeah, right. So remember, carbon monoxide consists of 2 oxygen atoms, guys. There are 2 oxygen atoms. So the question is asking for oxygen atoms. All right. Okay. All right. So list out all the possible conversion factor that we may need to use, okay, in the dimensional analysis. Like I said, I'm not going to show you the conventional method, okay, but later on maybe we can refer to the answer scheme. Okay, so we have CO2. CO2 given, the information given is in a form of volume. Okay, so 20.0 liter of CO2. Okay, all right, times, okay, liter of CO2. Okay, so far we have the relationship for liter, that has liter is the molar volume just now. Okay, so at STP we know that the molar volume is 22.4 liter. Okay, so the relationship that we have for this is 1 mole of CO2. Yep, CO2. Okay, all right, so this one later on will be cancelled out and then we will end up with mole of CO2. Okay, next would be ini ada additional lah so far. Okay, 1 mole of CO2. Okay, so we want this, we have the molecule of CO2, but the question is asking for oxygen atom. So how do we introduce that? But first, let's just write out the unit first. Okay, mole of CO2. Okay, kita carry mole of CO2. Okay, how can we introduce the oxygen now? How can we introduce the oxygen? Okay, all right. So we know that in CO2, for 1 mole of CO2, okay, for 1 mole of CO2, there are 2 mole of oxygen atom. Am I right? Okay, so that also could be used as our conversion factor. So for 1 mole of CO2 molecule, okay, has 2 mole, mesti mole lah, jangan 2, dah lah 1 mole, lepas tu ada 2 je oxygen atom. Okay, tak boleh lah macam tu, dia kena tally. If you have mole here, then should be you should have mole there. If not, if you are using 1 molecule of CO2, that means here should be atom lah. Okay, 2 atoms of oxygen. So 2, we have mole, and then this should be mole. Mole of oxygen atoms. Jangan O2 pula. Oxygen atoms. So this is also our conversion factor. Okay, alright. So for 1 mole of CO2, there are 2 mole of oxygen atoms. Okay, alright. Okay. But we cannot stop here, even though we already have in the form of oxygen atom. Okay, so we have to proceed a little bit further, okay, because the question is asking for number of oxygen atom. What we have here is in a form of mole. Okay, all right, so this one can be cancelled out and then we have to introduce, okay, saya sambung kat bawah ni tak muat. Okay, so as usual, this one, okay, the unit here should be written at the bottom, mole of oxygen atom. Okay, all right. So now, how do we want to introduce the number of entities? Remember last time, 1 mole of substance is equal to number Avogadro constant. Okay, so this is the time to apply it. Okay, so 1 mole of oxygen atom, 1 mole of substance of oxygen, okay, is equal to number Avogadro. So that is the relationship that we have so far. Okay, dia mesti ada kena-mengena. Okay, dia mesti related. The conversion factor is not just simply guna je apa nama tu any numbers. You should be able to justify why do you use this number. Okay, what is the relationship between them. Okay, so this one will be later cancelled out, and we will end up with the unit as oxygen atom. So next what you need to do is to tekan calculator, okay? Tekan calculator very apa nama tu, carefully, please lah, jangan salah. You calculate itu dah betul then you tekan calculation salah. Sorry your final answer will be wrong. Okay? Alright, so you end up with the final answer. Okay? Yep. That is how you use dimensional analysis. So you just have one straight apa nama tu line of the solution, working solution. You tengok kalau you are using the conventional, macam mana, how do you calculate that? Boleh share lah nanti. So bersepah-sepah ke ataupun cantik ke? How about the unit? Are you guys doing okay so far? Okay, inserting the unit for each of the figures, values that we have. Okay, if you are using dimensional analysis, I'm sure that you will be very much tersusun lah. Okay, ayu 5 o'clock already. Right. Okay, let's stop here. Any questions so far, guys? Okay, please complete all the checkpoints. We will discuss it tomorrow. Okay, I'll call up names for you to read out your answer. Or I also maybe, okay, I'll prepare a submission on the Google Classroom for you to submit the checkpoint. Okay, we'll see how, but prepare your answer. Any question, guys? Okay, if there is no question.
No, madam.
Okay, if there is no question, I think that's all for today. Thank you everyone for your attention. Okay, we'll see you tomorrow for our 1 hour lecture. Okay, with that, Assalamualaikum and bye.
Bye, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Okay.
Thank you, madam.
Thank you, madam.
Thank you, madam.